Hey there, Internet. So I got my giant steel tool cart, and I got four nice plates of 3/16 inch steel, 2x3. I got four of them off the bottom here, so I can still use these shelves. I pulled some of these off. This whole top surface was covered in these pieces of U-channel. So I have the mill sitting on a bunch just for really good support. And I have my crappy backsplash to keep the chips where they're supposed to be there. And then on this side, I have a decent steel table to work on. And I still have the four plates from down below. The other change over here that I'm testing out is I bought a couple more of these closed loop stepper drivers, and I changed the X and the Y out. I'm going to eventually do the Z. I need to make a new mount, but I changed the X and the Y, and the machine seems to be running really good. So what we're going to do today is I'm going to make a This Old Tony style tap holder, tapping wrench. So I had tried to make at one of these Joe Pye's style tool holders, and it went really well. I got the bolt in there, it's all counterbored in. Unfortunately, when I drilled the center hole here, you can see that my drill wandered out the side. It started out okay, and then on this side it completely wonkified out the side. So I mean, I'm going to try to make another one of these and probably cut the single corner square hole. But today we're going to make a different style one. This Old Tony made a video about one of his favorite style tap wrenches, and I need a small tap wrench. So I have one of these things, and this thing is completely worthless. It's I think it looks like metal and it feels like metal, but it's some kind of like metallated plastic from China. I don't know what they made this out of, but it just you need to get 6 wrenches to tighten the wrench, and it's awful. So we're gonna try to make one out of some steel, and I'm not sure of the design, so I'm just gonna use a roughing end mill to see if the tool paths work, and then test it out. So let's go look at the cam, and then we'll cut it out on the CNC machine. Here's the model that we're going to be working with. Because I don't know hardly anything about this, we're only going to be doing this top side here. The bottom side we're just going to leave the way it is. The holes, this is a 6mm hole, and this is a 5mm hole meant to be tapped. And this is one of the things I really wasn't sure about. It was the depth to make this. I believe, let's look at the sketch real quick. Let's look at the other sketch. All right, so one of these is 2mm deep, and the other one's 1.5mm deep. I don't really know what the right size for this is. I think these will work for my smallest taps, but I'm not really sure. Again, this is a prototype, so it's no big deal. The distance between the top and the bottom is 10mm. The overall length is about 32mm. The center distance between the cylinders is 15mm. So I'm shooting this after I've actually already run the CNC job, and one of the things that I didn't do is flip the parts. So I actually milled the exterior and bored these holes, and then did the tool change, and then I did a flip of the part in order to get the depth here to match the depth here, because this 5mm hole has to line up, or I'm sorry, this 6mm hole has to line up with this 5mm hole. So the part needs to be it needs to be flipped around in order for that to work right, I think. Maybe it just works the way it is.
I don't really know. I've already done it and I have no idea. Oh, geez. Well, anyway, what else can I tell you about this? The other thing I guess I can tell you about this is the first cut on the end here. The bandsaw cut was super crooked, so I have like I think about 15 millimeters on one side and about 13 millimeters on the other side. So I have a whole bunch of extra room in the Z here that needs to be removed. That's just because the end of the scrap piece that I had that I'm going to make this out of wasn't square. The tool paths that I'm using, I'm doing a 2D adaptive where there's roughly 4 millimeter step down, and it's on the climb cuts is 0.6 millimeter step over, and on the regular cuts it's a 0.4 millimeter step over. Next thing is a bore operation, and this was probably the thing I was most worried about, because the way that this is clamped in the vise, there's only a couple millimeters down in the bottom here holding everything, and my tool is only 11 millimeters deep, and because of my crooked bandsaw cut, I risked a bit of a collision if I did the bore first. So I did the adaptive first, but really the bore should happen first, and there should be less extra stock. So I would do the bore while it's held really, really firmly, and then the contour, this last pass just takes off a wee bit on the bottom, and so the closer you get to the bottom, the less material is holding it in the vise. So it's best to do that operation last. And then because I don't have the paid version of Fusion 360 and I don't have a fully automatic tool changer, the next step is to put in the chamfer mill and cut the chamfers. I haven't done a whole lot of chamfering on the machine, and I tried about 16 different things before I figured out what to do. And I think the best solution for me was to do a 2D contour for the regular chamfers, and that way you can, because they're modeled in, you can just select this bottom profile. You couldn't select the whole profile, you had to select the partial profile, because it would extrapolate a different profile if you use the standard selection. I guess I can show you that real quick. So if you select that edge, it drops everything down for some weird reason to this point, and that's not what you want at all. So I'll cancel that and go back in here. So what you really want to do is just use Alt and select the individual tool paths, and so it skips this weird extrapolation where it tries to drop everything down to this point. And then the tracing operation, this one also was kind of funky. There's no multiple passes, and what you have to do is you have to select this additional, or this offset passes, and then you select the maximum number of step downs, or the maximum size of the step down, but you have to manually select how many step downs. And so that kind of threw me for a loop. In the program, it's hard to see because of the stock, it doesn't have any rest matching, but there's 4 step downs here, and you'll see that when I cut the part out. So I think that's everything in the cam. It's probably a bit long-winded, but let's go to the CNC machine and cut it out.
I want to make sure I'm not going to crash. I have like a whole 1/2 millimeter. I guess that's good enough. Circle Looks real good. I guess here goes nothing because I had to flip this right model and I don't know if I did it right. So here's to break in my new end mill. Power on. Oops. I forgot something. What I did there was I tried to do a tool offset and I hit the wrong button in the stupid sender because it's so confusing. You can't figure out how anything works. And so I set my Z height back to this surface, but the stock offset was 2.5 millimeters above that. So it plunged down to minus 2.5, which was really like way into the part here. It's not the end of the world, but I've changed the offset. Hopefully the tip survived, and we'll try it again. That looks better. Okay, so here's the finish. They're both slightly undersized. Nothing I can't fit with a fix with a reamer. This hole here is going to get tapped anyway, so it's no big deal. This is a 0.5 millimeter. I'm sorry, 4.9 millimeter drill, and this is a 5.9 millimeter drill. So just a wee bit loose. The external surface finish with the rougher feels and looks much better than I thought it would. The top surface finish looks pretty good, and my slots look pretty good. Now, I had a whole bunch of issues with my cam, which I should fix. There was a bunch of air cutting happening. But what I'm going to do next is go ahead and clamp these in the manual mill and just clean off this bandsaw edge. And then I'm going to thread it. And I just want to kind of see how I like it before I go ahead and try to put the chamfers on the other side. So let's go over to the manual mill and we'll just deck that off real quick. So I didn't quite get all the way through. Okay, here it is. So one of my goals was this would continue to center on here, as well as to have it lock in on the sides. And because this is only 5 millimeters, I can do that. I think I can actually. I'm sure it has enough grip that if you choked up on it, that would also work. I mean, it's let's see, it's about 10 millimeters thick, so it's a total of 20 millimeters. Um, that's got to have more than enough grip. Let me find. Let's test it out on something ridiculous. I didn't plan this at all. It really happened to just be here. I have no idea what size hole this is. But it's wood, it's plywood, it should be okay. Yeah, this feels okay. I think the handles are going to need to be really quite small and stubby. Um, but you know, I can parameterize the design fairly easily and have multiple sizes. Yeah, that works pretty good. I wonder, the handle offsets, they don't seem to throw you off all that much. I suppose I could shrink this width down a little more. It might make it a little better. But that works okay. I wonder how it'll work for a bigger tap. So there it is. I guess the next step will be to make some handles for it, and then maybe clean it up. It's not going to need a whole lot of cleanup. Probably worth it to make some handles, maybe 40 millimeter jobs. I wonder if I should just leave some facets on the handles just so I can grab a wrench, or if it's better to use like a bolt and just have something threaded, the bolt threaded through something. Because I don't know if you're gonna, even if the handle's this big around, if they're that short, I don't know that you're gonna have enough crank to tighten it down as much as you're gonna want it tightened down. I just don't know. But yeah, I'm rambling at this point. So yeah, what did I learn? I like those 4 millimeter roughers for sure, and most of the tool path was good. The chamfer worked out really well, and cutting the slot, I kind of wish it would offset on its way down. The engraving toolpath does that, but you need an enclosed shape to do the engraving, so I had to use trace. Yeah, so stay tuned for next time. I'll make the handles, probably do it on the CNC lathe, just so I can do easy tapers, and maybe we'll make another set and use a better quality end mill on this outer surface finish. Thanks for watching.